Good morning, sir. Myself, I am KM Saivana. I am from Triple Branch. My roll number is 244G1A0246. Today, my topic is verify Gauss's divergent theorem. Verification of Gauss's divergent theorem. Applying the theorem to f is equals to xyz I to x square yj plus zk over a cube. Introduction to Gauss's divergent theorem. Gauss's theorem states that the flux of a vector field through a closed surface equals the volume integral of its divergence. Problems definition. Given vectors field f is equals to xyz I minus zx to x square yz plus zx. Cube boundaries. X is equals to minus x is equals to 0 to a. Minus y is equals to 0 to a. Minus z is equals to 0 to a. Computing the divergence of frequency f. Divergence formula. F is equals to given p is equals to xyz, q is equals to minus 2x square y, r is equals to z. Delta f is equals to yz minus 2x square plus 1. Evaluating the volume integral. Integral v yz minus 2x square plus 1 dv. Integral over cube. Integral o greater than a, integral o greater than a, integral o a yz minus 2x square plus 1 dx dy dz. Computing value integral. Solving integral step by step. First integration in x, then y and z. Obtain final result. Surface integral approach. Flux calculation. Integral s f ds. Consider 6 phases spiritually. Minus x is equals to 0, minus y is equals to 0, minus z is equals to x is equals to a, y is equals to a, z is equals to a. Flux across x is equals to 0 and x is equals to a. At x is equals to 0 and f is equals to 0, 0, 0. So flux is equals to 0. At x is equals to a, f is equals to a yz minus 2a square y z. Integrate 0a yz dy dz. Flux across y is equals to 0, y is equals to a. At y is equals to 0, f is equals to 0, 0, z. So flux is equals to 0. At y is equals to a, f is equals to a z minus 2a square a comma z. Summing the surface integrals. Total flux across all faces, sum of individual fluxes. Compute and compare with value integral. Comparison of volume and surfaces integrals. Value integrals result, surfaces integral results. This confirms Gauss's divergence theorem. Physical interpretation. Gauss's theorem represents conversion of field over a region. Applications of Gauss's theorem. Electromagnetism used in Maxwell's equations. Fluid dynamics, flow calculations, engineering, heat and mass transfer. Conclusion. We verified Gauss's theorem for the given vector field. The theorem is useful in many physical applications. Thank you, sir.